And here we are back in Math 1. And this is, again, the idea of graphing. We're going to combine a graph with a linear equation. So two equations and find out where they intersect. We had a question just like this on the released form. So on the North Carolina Practice EOG. So let's take a look at that just to remind you. And so when you have something like this, two functions, so maybe you didn't know what functions meant, but it just meant two equations. So f of x equals that is the same as y equals that. Okay, so your input is a number and your output is a number, x and y. And the difference, of course, is that we have one has a squared term and the other doesn't. And so this is a quadratic or a nonlinear. And then this one just has that coefficient x. It's a linear, so it makes a line, 11x plus 13. So hopefully you. And so what you could have done in this one is you could have just substituted in the values. And so, for example, when you do 2, you put 2 into the first one. 11 times 2, 22 plus 13 is indeed 35. So you say, well, that might work, right? And then when you think about it, you think, well, I've got a parabola type shape and I've got a line shape, so there's probably 2. So then you try the other ones. And when you put in -5, that doesn't work in the other one. You put in a -3 and you get -33 plus 13 is -20. And you find out that one works. So these two both work. They're 2 points that work in the g of x and the other one doesn't. And so then you think, well, I could try that. Then if you're feeling motivated, you would go and see if those points actually worked in the other one as well, okay? And so let's just try it with 2 times 2 and 35. So does 35 equal output if I do 3 times 2 squared plus 14 times 2 minus 5. So that would be 12 plus 28 minus 5, which would be 40 minus 5 equals 35. Yeah, and the other one would check out that way as well. But we're going to talk about a way to do that without the guess and check. But first we want to look at this. So let's suppose that we start off with the graph. So we start off with that graph of x squared minus 4x minus 4. So we've got that graph. So we use Desmos to make this nice graph for us. And we see when x is 0, we get -4. So we have that point -4. And we almost have a 0. It's not quite 5. So let's see what happens when we put 5 in there. Value at 5 is 25 minus 20 minus 4. Value at 5 is 1. Okay, so 5 is 1. It's a little bit before there. So let's see where this intersects with y equals x plus 2. Okay, so remember y equals x plus 2, that long ago thing we did where we made lines based on the equation. And if you're not sure about that, you can make a little table of, well, what do I have with x and y? So if I put in 0, I get 2, 1, I get 3. But this one's so easy that you say, well, what's the y-intercept? Well, when x is 0, y is 2. Okay, what's the slope? So what's the slope of this line? Well, it's just 1, right? It's just 1. There's no coefficient on the x. So you say, okay, if the slope is just 1, I can just draw this line. And there we go. And so it looks like I found these 2 points of intersection. Okay. So in fact, it looks like -1, 1. And up here, it looks like we have 6, 6, 7, 8. Looks like we have the point 6, comma 8. Okay, and we can test those out and see. So we could say Minus 1 squared is 1. 1 minus 5 is minus. Oh, sorry. So it's 1. Minus 4 minus 1, okay, is plus 4. So we get 1. 1 plus 4, 5 minus 4 is 1. Okay, so that point checks out. And then 6 and 8, so I'll have 36 minus 24 is 12, minus 4 is 8. So that point checks out. Now, what if we said, you know what, we really want to try and solve this algebraically? Well, what we see is that for both these points, right, so x, that x, is going to give the same value. And so, for example, if I put 6 into the quadratic, I get out 8, and I put 6 in into the linear, I get out 8. So we can set those equal. So that's the insight that you needed to use this algebraically, is you just said, oh, well, the x values are going to give me the same y for both equations, so I can set them equal to each other. So it's a classic substitution. Okay, so if you have this, say I can solve this, right? And you say all I need to do is get everything on the same side. So I subtract x and subtract 2. Subtract x, subtract 2. And in doing so, I now get x squared minus 5x minus 6, okay, equals 0. And when you do that, say, I wonder what I'm going to get. It looks like I can factor that, right? I have a new quadratic. And so you say, okay, I'm going to factor that. And I get, so it's an x plus, and an x minus. And in order to get a difference, so I can do either 1 and 6, they have a difference of 5, 2 and 3 have a difference of 1. So it looks like it's 1 and 6, and it's negative, so it looks like it's x minus 6 and x plus 1 equals 0. So even though I don't even know why this would work, I find that I get then x equals minus 1 or x equals 6, which is exactly what we had. And so then you say, okay, well, I can put that in. So what's my y? So you just say, well, y equals x plus 2. So y equals minus 1 plus 2, y equals 1. So there's one of your points is minus 1, 1. And then you solve for the other one and say, I have y equals 6 plus 2, y equals 8. Okay, so then you have the other point, 6, 8. And you could try them in your quadratic too, but I think, based on what we've seen, that looks like they would work. And so that is the problem that we had on that release form. And so here Desmos made that nice solution for us. It said, yeah, there's a point. There's the point's intersection. And it said, oh, by the way, here's the y-intercept and the x-intercept of that line. Thank you, Desmos. Okay, so now, not every parabola faces up. So if we put a minus sign in front of it, minus x squared, oh, it looks like the minus sign got lost there. Let me just double check in Desmos. More than the minus sign got lost. So this is minus 2x squared minus 4x plus 5. And we're going to see about having another equation and see where it intersects. Well, so if you look at these two, and y equals 2/3 x, so we have a quadratic and a linear. But what you'll notice is that they both have the same y-intercept. And so you find, oh, well, I already know a point of intersection, which is 0, 5. 0, 5. 0, 5 is both on the curve, and it'll be on the line. And then you say, well, I don't have to do anything else because I can just use slope. So slope is up 2 over 3. So let's just build that in. So we go up 2 over 3, and there's a point for us. Up 2 over 3, and then we can go back 3, down 2, back 3, down 2. And as we do that, we see that we get another point of intersection, but it is not on a lattice point. It does not appear to be on a lattice point. So we can kind of approximate where it is. And say, okay, got that line, kind of muck that up. But it looks like it's close to so -1, -2, -5 halves. It's close to -5 halves 3. Okay, so we say, okay, there's our 2 points of intersection. But we could find out an exact answer. So let's see if we can. Okay, let's try the same thing. So it's a little bit more complicated. So we have minus 2x squared minus 4x plus 5. And we'll set that equal to our other equation. 2/3, not 3 halves, 2/3 x plus 5. Okay, so then you think, well, this might not be so hard, right? It's going to be -5, and then I'm going to subtract minus 2/3 x from both sides. So I'll have all that equal to 0. And I'll have on this side, I'll have minus 2x squared. Then over here, let's say, so it's 12/3 minus 14/3 x. And that's it. That's it, right? The -5 and the +5 cancel out. And so I look at this saying, well, I'm not sure what to do, but maybe I can divide by 2. Divide everything by 2. How about by -2? So then I get x squared plus 7/3 x equals 0. I'm trying to think, what's the best thing that I can do? So can I do this? Can I do x plus 7/3 equals 0? And it looks like I can, right? So then I get, if I do that, I get x equals 0 or x equals minus 7/3. And so that's 2 1/3. So we thought it was around 2 1/2. And when we look at that, let's see if it works in our equation. So we have y equals 2/3 x plus 5. And let's see what we get. So y equals minus 7/3 times 2/3 plus 5. So y equals minus 14/6 plus 5. Y equals minus 7/3 plus 15/3 equals 8/3. Okay, so in this case, we don't know for sure. We say, well, okay, that might be. Say, so we're claiming that the point minus 7/3, 8/3 is on both lines. Well, we just showed that that point is indeed on the linear equation, and now we have to show that it's on the other one, the minus 2x squared minus 4x plus 5. Minus 2x squared minus 4x plus 5. Okay? So if this is true, then 8/3 equals minus 2 times minus 7/3 square, quantity squared, minus 4 times minus 7/3 plus 5. Okay, and you look at that and say, well, maybe, I'm not sure. So minus 2 times, and this will be minus 49 ninths. Except it's minus times minus, so it'll be plus. And then this will be minus 20 plus 28/3 plus, so let's just make this into 15/3 and see what we get. So we get 8/3 minus 98 equals minus 98 ninths. Oh, we're gonna have to change everything to ninths. Maybe we do, right? Okay, so it's minus 98 ninths. And then this is plus 84 ninths plus, what would this be? 45 ninths. So make this into ninths too, so that times, so it would be 24 ninths equals minus 98 plus 129, is that right? 129 ninths. 89, 98, transpose those. '98 plus 84 times 49, 80, 98, 60, 84. So it looks like it's slightly off. 31 ninths is what we get there. So don't seem like we've got the right answer for that one. Let me see. And so we'll just double check our work here. So minus 2x squared minus 4x squared is 7 times 7, 3 times 3 is 9, 8/3. So let's double check if it was really 8/3. Okay, so our answer here, intersection seems to be a little bit more than 8/3. So let's just double check that. So, so there you see it. Just think of how many times you've made this, a teacher yell at you for this. So we're multiplying, and what have I done? So we look at this and say it's minus 14 ninths, okay, plus, so now 5 would be 45 ninths. So there we have 31 ninths. 31 ninths. Yeah. Okay, so then with 31 ninths, let's see how we do. So now we say, oh, no, it was never that. It was always 31 ninths. And you get down to here and you say, how about that? That's right. It is 31/9. So they take, so from 98 to 129 is 31. Okay, and so that would be the way to solve that one. Okay, so then you say, well, all right, what if I got on this test and I didn't want to do substitution, or worse yet, they didn't give me the chance to do substitution? Okay, hopefully now you've got the idea that you can set these equal to each other. So we've got a quadratic, and we've got a very steep line, right, 11x plus 13, and they're going to have 2 points of intersection. So we can solve for the points of x that are in both. So we say 3x squared plus 14x minus 5 equals 11x plus 13. And so you've got that. And you say, well, I'm going to put everything on the same side. So I'm going to subtract 11x and subtract 13. And you get 3x squared plus 3x minus 18 equals 0. And then you look and say, well, happy day. These are all divisible by 3. So I can make that a lot simpler. So I go x squared plus x minus 6 equals 0. Okay, so I've got a minus and a plus. So it's an x minus and an x plus. And it has to be 6, so it's 1 and 6, or 2 and 3. These two are 5 apart. These are 1 apart. So, oh, there you go. It must be that. And it's plus, so the 3 must be here and the 2 is there. So we get x equals 2, or x equals minus 3. And then since they gave you those, you could work on that. But you could have just said, okay, 11 times 2 plus 13, or 11 times minus 3 plus 13. So you would have had 2 went with 35, or the value you get out of this is minus 33 plus 13 minus 20, or minus 3 minus 20. Okay. And that is how you could have solved those. So, but again, until you've seen it done, you're not really sure what to do.